Hello everyone. In this video, I will explain how to synthesize passive RC circuits using two cover form. There are two cover forms, first cover form and second cover form. The impedance function is given as this one. We said RC S is equal to S plus 1 times S plus 3 over S into S plus 2. Before synthesis the passive network, we have to check the given function is realizable or not. For that one, there are some properties. These are the properties of passive RLC function. There are six number of properties. We have to check whether the given function is satisfy all the condition. When the first property is it must be a rational function in S with real coefficient. The given function is it has a S coefficient, then first condition is already satisfied. There are real coefficients plus 1, plus 2, and plus 3. There are no imaginary coefficients. And second one is may not have pole or zero in the right half plane. When we consider this function, there are two poles and two zeros. Poles of this function is equal 0 and is equal minus 2. And there are two zeros is equal minus 1 and is equal minus 3. From the numerator, we can obtain zeros. From the denominator, we can obtain poles. Now, I draw the complex S plane. This is real axis. This one is imaginary axis. There are two poles at the origin. S equal 0 and S equal minus 2. Minus 2. And there are two zeros. S equal minus 1 and S equal minus 3. The right half plane is this one. You can see all the poles and zeros are in the left half plane. Then second condition also satisfied. The third one is may not have multiple poles or zeros on the. This is multiple zeros on poles. When we consider these poles and zeros, there are no any multiple poles or zeros. Then third one also satisfied. And fourth one is may not have degree of the numerator and the denominator differing more than 1. When we consider the function, the degree of the numerator is 2 and the degree of the denominator is 2. The difference is 0. It is less than 1. In the fourth one says it is differing by may not have degree of the numerator and denominator differing more than 1. The difference is 0. Then this condition also satisfied. And the fifth one is must have non-negative real part for all S equal j omega. For that one, we have to assign S equal j omega. We said RC j omega is equal to j omega plus 1, j omega plus 3, j omega plus 2. Now we have to solve this one. 3 minus omega squared plus 4j omega is the numerator and the denominator is minus omega squared plus 2j omega. To obtain the real part, we have to multiply both the numerator and denominator by complex conjugate of the denominator. Minus omega squared minus 2j omega. Minus omega squared minus 2j omega. Then after multiplying these 2 by complex conjugate of the denominator, we can obtain omega 4 plus 5 omega squared plus j times 2 omega cube minus 4 omega squared minus 6 omega over omega into the 4 omega square. The real part of the Z RC j omega is this one, omega to the power 4 plus 5 omega square over omega to the power 4 plus 4 omega square. This is the real part of the function. It says must have non-negative real part. This is non-negative greater than 0. Then fifth one also satisfied. And the last one is must have positive and real residues for poles. For that one, we have to do the partial fraction expansion of this function. The partial fraction expansion is equal to 1 plus 302 OS plus half S plus 2. These are the poles. The sixth property says must have positive and real residues for poles. And these are the residues. You can say both are real and positive. Then last condition also satisfied. Then we can do the first Cauer form. To develop the circuit, we can apply first Cauer form at the first Cauer. For that one, set as is equal to s squared plus os plus 3 over s squared plus 2s. This is the expansion of this ZRC function. Then I can apply the continued fraction expansion. S squared plus 4s. This is the numerator plus 3 and the denominator is s squared plus 2s. From this one, value is 1. I will multiply this function by 1, s squared plus 2s. After subtract these two, 0 plus 2s plus 3 is the answer. And this part we can use in this place plus 2s. For this one, answer will be s over 2. When I multiply this by this function, s squared plus 3s over 2. Now I can subtract these two. 0 plus s over 2. Then this part 2s plus 3. Answer is 4. When I multiply this one by 4, it is equal to 2s. The subtraction is 0 plus 3. And the last one is s over 2. Answer is s over 6. When I multiply 3 by s over 6, I can get s over 2. The final answer is 0. We applied the continuous fraction expansion for impedance function. Then this value will be impedance. This one is admittance. Z1, I name as Z1. Y1 is again impedance. Z1, Z2. And this one again admittance. Y2. This is a RC network. If we consider the impedance of the capacitor, ZC is equal to 1 over Cs. And when we consider the admittance, it is equal to Cs, 1 over Zc. And if we consider our resistor, impedance of the resistor is R and admittance of the resistor is given as 1 over R. Then if we consider these answers, Z1 is equal to resistor. It is a resistor. And considering the Y1 is equal to a capacitor. It is a capacitor. Value is 1 over 2. For this one, value is 1. And Z2, it is again a resistor. Value is 1 over 4. 1 over 4. Sorry, it is a 4, not 1 over 4. Because it is a impedance value. When the impedance of the resistor is value of the resistor, then this is the impedance value, then the resistor is value with 4 ohm. Capacitor is 1 half farad, resistor is 1 ohm, and the last one is this admittance. It is equal to admittance of the capacitor. It is a capacitor, and the value is 1 over 6 farad. Then we can construct the final circuit. The first one is the impedance value. It is connected in series, and second one is connected in parallel, again series, and again parallel. It is like a ladder diagram. It is like ladder. First one is series, second one is parallel, and third one is resistor, and the final element is capacitor. We can measure the ZRC from these 2 points. This is ZRC. The value of the resistor 1 is 1 ohm, resistor 2 is 4 ohm, and capacitor 1 is half farad, and capacitor 2 is 106 farad. This is the final circuit from that we can obtain from the first Cauer form. In the first one is construct the circuit diagram for following RC impedance function using the first Cauer form. This is the impedance function, and obtain circuit is this one after applying the first Cauer form. Then we will move to the second Cauer form. For that one also we have to use the continuous fraction expansion, but there is a one difference. For this one, ZRC is equal to S squared plus 4S plus 3 is the numerator, and the denominator is squared plus 2S. We have to rearrange these two equation in ascending order of s to the power s to the power value s0, s1, s2, s3 likewise. If I rearrange, the function will be like this: 3 plus 4s plus s squared, 2s plus s squared. 3 is the s to the power 0 value. This one is s to the power 1, and this one is to the power 2. The previous one, it is in descending order. S squared, s, and s to the power 0. In the second Cauer form, we have to rearrange these two functions into the ascending order of s to the power. S to the power value. The denominator is 2s plus s squared. Now we can apply the continuous fraction expansion. The numerator is 3 plus 4s plus s squared, and the denominator is 2s plus s squared. For this one, answer will be 3 over 2s. Then I multiply this by this. I can get 3 plus 3s over 2. Now I subtract these two. 0 plus 5s 5s over 2 plus s squared, and next 2s plus s squared from this one, and the answer is 4 over 5. And when I multiply 2s plus 4s squared over 5, the subtraction is 0 plus s squared over 5. Then third one, 5s over 2. This is 2 plus s squared. Answer is 25 over 2s, and 5s over 2. The subtraction is 0 plus s squared. Squared plus squared over 5. Answer is 1 over 5. Squared over 5. Final answer is 0. For this one also, we consider the impedance one. Then this one is impedance value Z1. This one is admittance value Y1. This again impedance Z2, and this one again admittance value Y2. Now we have to select what are the element. For this one, it is equal to equal to a capacitor. You can see impedance of the capacitor is 1 over Cs. Then this is a capacitor. The value is 2 over 3 farad. And next one is resistor. YR is 1 over R. Then the value is 5 over 4 ohm. And the third one is capacitor again. Z is 1 over Cs. Then the capacitor value is 2 over 25 F. And the last element is again resistor. Value is 5. When you consider the each element, first one is connected in series because it is impedance value. Next one parallel, again series, and final one is parallel. It is like a ladder. The final circuit is first element is a capacitor, second one is a resistor, third one again capacitor, and the final one is resistor. We can obtain the final impedance value from these 2 points, ZRC. The capacitor one is 203 farad. Resistor one is 504 ohm. Capacitor 2 is 2025 farad. And the resistor 2 is 5 ohm. This is the final circuit that we can obtain after applying the second Cauer form. Resistors are series connected in parallel and capacitors are connected in series. In the first Cauer form, resistors are connected in series and capacitors are connected in parallel. This is the opposite side of the second Cauer form. And this is the process that we have to follow when we apply in the first Cauer form and second Cauer form for synthesis of RC networks. I hope you all are clear about this example for the first Cauer form and second Cauer form. Thank you.